All right, y'all. We are looking today at the 3-7 notes, quadratic functions in vertex form. Okay, so the first thing we start with is just a quick definition right up here at the top. A quadratic function means that it is a function y equals something, and that something includes the highest exponent of 2. Okay, so that means somewhere in every quadratic function, your largest term is x squared. Okay, that's your key feature that makes it, that is the defining feature. What makes something a quadratic function is that it is x squared. Now, the first thing I want to point out, first thing I want to show you is the parent function. Okay, so here in the calculator, I'm just pulling up this so I can show you what the basic x squared function looks like. Okay, we hit graph, it pulls up this shape right here. This is what is called a parabola. Okay, that's a word you probably heard back in Algebra 1 describing x squared functions. Okay, this is a parabola. It has a couple of key features about it. The first thing is that the first thing you notice is right down here at the bottom. There is a point where this comes down and it hits that point and then it turns around and starts going back up. Okay, that point, just like we talked about when we studied absolute value functions, that point is called the vertex. Okay, so what we're talking about today is the vertex form of functions that look like this. Okay, the vertex form, we have a bunch of stuff. Okay, we have y equals, we have a and h and k that will all affect how this original parent function version of it changes. Okay, so the first thing is that if you have a negative number in front of these parentheses, a negative a coefficient out here, it will reflect this parabola across the x-axis. So I'm going to leave that parent function on there, and then I'm also going to put like negative, a negative sign in front of our x squared. Okay, so we'll have the original in blue and the reflected one flipped over upside down in red. Okay, so it's just like we studied, just like we did back with absolute value functions. It just flips it over upside down, reflected over the x-axis. If we have a number bigger than 1, a coefficient, a large number out in front of these parentheses, it will have a vertical stretch. So this time I'm going to keep the parent function on there, and I'm going to put I'm going to put 4x squared. Okay, so the original comes up in blue there, and the new one, the vertically stretched out one, gives you a skinnier parabola than the original one did. Okay, that's what we were expecting. On the other hand, if your coefficient out in front of it is a smaller number, I'm going to look at an example right here. What if we had like 0.5 x squared? So it'd be 1/2 x squared. Okay, we have the original graph in blue, the parent function, and then in red is going to be our modified one, and that would give us a vertical compression. That means it's a fatter parabola than the one that we started with, shorter and fatter. Okay, let's talk about adding and subtracting numbers. Okay, when I look at something like this, if I am adding numbers on the inside of parentheses, that is my horizontal shift. Okay, and this is the same rule you'll remember from when we talked about absolute value functions. You have to remember that insiders lie. Okay, make sure you scratch out these arrows right here and draw the arrows to the right thing. These two things right here are where you look at the fact that insiders lie. Okay, so I'm going to keep the original parent function. I'm going to put, this time, I'm going to put x minus 3 squared. Okay, so you notice that we are subtracting a number, so we should expect our new function, our modified one, to move to the right. And when you look at it, we have the original parent function, and then our modified one moved exactly 3 units to the right. Okay, you'll notice that vertex is no longer at the origin, it's 3 units directly to the right of the origin. Okay, and then if you're adding a number on the outside, this k number on the outside, if you add or subtract, that would move it up and down, your vertical shift. Okay, so we had a vertical, horizontal shift right there. I'm going to add 2. So with our parent function, we're now going to have that same parent function, and now our modified one is going to be moved to the right by 3 units and moved up by 2 units. See, the vertex is now over here at 3, 2. Okay, and so that is some of the things that we're going to be looking for today. Okay, the things that we're looking for on all of the functions that are given to us here are the transformations, okay, your either stretch or compression, your reflection, your horizontal and vertical shift, and then we're also going to be looking for the vertex and the axis of symmetry. Okay, look at this picture right here. I already described the vertex. Okay, the vertex down at the bottom of the parabola or up at the top, right? If it's one of those flipped over upside down, the vertex is that point where it turns around and goes the other direction. The axis of symmetry is also very much like when we talked about in absolute value functions. It is a vertical line that goes through the vertex. Okay, it's a vertical line that cuts that parabola in half where you've got mirror images on both sides of it. Okay, so take a look at problem number one. I look at problem number one and I see that we've got plus 2 on the inside of these parentheses. If we've got plus 2 on the inside of the parentheses, that means we are moving to the left by 2 units. I also see that we've got minus 1 on the outside. That tells us that we're going down by 1 unit. Now, when I think about the vertex, back on the front page, we had a little bit of interesting information right here. What we're going to do is we're going to take the opposite sign of h, okay, whatever that number added or subtracted on the inside, we take the opposite of that, and the y-coordinate comes from that number that's added on the outside, added or subtracted on the outside. So when I look at this, we've got plus 2 on the inside, minus 1 on the outside. Our vertex is going to be located at minus 2, minus 1. Okay, we flipped that first one. We kept the second one the same. Okay, and the reason for that is because we know that we moved to the left 2 and down 1. In the parent function, whenever we were looking at that, the parent function always had the vertex right at the origin. Well, when we do a shift, the thing that we are shifting is that vertex point. So if we go to the left by 2 and down by 1, well, that is the point, negative 2, negative 1. Now, we also know that the axis of symmetry is a vertical line. So its equation looks like x equals some number. That number is the same as the x coordinate of the vertex. So if we have negative 2 for the x value of our vertex, then the axis of symmetry is x equals negative 2. All right, that's one. This is the type of problem that you don't have to overthink sometimes. Okay, take a look at problem number 2 on here. Okay, problem number 2, the first thing I see way out here in front is that we have a negative sign. Okay, that negative sign right there tells me that our entire parabola is going to be reflected over the x-axis. Up next, I see that we've got minus 1 on the inside. We remember that insiders lie. So for us, that means we're moving to the right by 1 unit. And we've got plus 2 on the outside. That tells us we're going to be moving up by 2 units. Okay, so there's 2 ways you can think about it. Okay, one way you can think about it is if you took that origin point, that vertex, and moved it to the right by 1 and up by 2, your new vertex would be located at 1, positive 2. But if you're just looking at the equation, just looking at the numbers, you see minus 1 and plus 2, you change that over on your vertex to plus 1 and plus 2. All right, we also know that our axis of symmetry has the same x-coordinate, so we call it 1 and be done right there. All right, problem number 3. First, the very first thing I see is that negative sign, so we know it's going to be reflected. And we also have a coefficient out in front of it. Okay, this coefficient is a larger number. Okay, that's a number larger than 1, so that means it's going to be a vertical stretch by a factor of 2. On the inside of the parentheses, we've got a plus 1. Remember that insiders lie, so we're going to the left. And the question, do we have anything added or subtracted on the outside of the parentheses? No, we do not. Okay, so we ask the question, what does that mean for our vertical shift? Well, what that means is that there isn't any. Okay, if you don't have anything out there, that's the same thing as if you added plus 0, right? Adding plus 0 doesn't change anything, but what that does is it indicates that that's still going to be the coordinate of your vertex. It's going to be minus 1 and 0. Okay, and your axis of symmetry, of course, also going to be -1. Okay, we move on over to number 4, and we see that we've got a coefficient out there, so it's going to give it a vertical stretch. We know it'll be a vertical stretch by a factor of 3, but there isn't anything else. There's like on this problem right here, we don't even have any parentheses. How are we going to deal with any numbers that are subtracted in the parentheses if there aren't any? Okay, on that note, we don't have anything added or subtracted outside of parentheses either. What that tells us is that there is no vertical shift, there is no horizontal shift. So that means our vertex is in the exact same place as our original parent function that we were dealing with over here. It's right there at 0, 0. And that means the axis of symmetry is that vertical line, x equals 0, also known as the y-axis, right? Okay, so these bottom two problems, we're doing the exact reverse of what we just did on the first ones. Okay, these bottom problems, it describes to us the transformations, and we have to write the equation. Now we know for sure that all of these equations are going to have some stuff in common. Okay, we're going to have some parentheses with x, and those set of parentheses are going to be squared. But we need to figure out if there's going to be any coefficient, if there's going to be anything added and subtracted inside, if there's going to be anything added and subtracted outside. Okay, that's what we need to figure out. So when I look at this right here, I can see that we've been shifted down by 7, and we've shifted left by 3. So if we're talking inside the parentheses, we remember that insiders lie, right? And so we look at left by 3. You would think -3, but we know that's not true because insiders lie. It's going to be +3 on the inside. We look at the other one, down by 7. That's on the outside. That's your vertical shift. So we go -7. All right, take a look at your next one. Quadratic equation shifted up by 3, right by 5, and reflected on the x-axis. So we know for sure there are some things that are going to be in every problem. We know that we're going to have parentheses. Oh, sorry. We know that we're going to have some parentheses with an x inside. Those parentheses are going to be squared. We're going to have numbers. We could have numbers before, inside the parentheses, and added or subtracted outside the parentheses. So we look, first thing I see that it's reflected. That means we're going to have a negative sign. Before we're even dealing with parentheses, we have to have a negative sign. Okay, this thing is reflected over the x-axis. But if we're moving to the right by 5, your first instinct says +5, but that's wrong because insiders lie. We've got to go -5 on the inside. And if we're going up 3, that means we're going +3 on the outside. All right, your homework problems are very, very similar to all of these right here. Okay, if you have any questions, please let me know. All right, I can help you out if you just let me know. That's all we've got for today. Y'all have a good one.